Hello dear students, let us see divide operation in relational algebra. Very interesting operation. That is why the topic of divide operation will span for 3 videos. But the meaning of divide operation will be very clear in this particular video. Now note, division operator is indicated between the two tables or two relations R1 and R2 with this divide operator. Many authors write this as R1 divide R2, where R1 and R2 are two relations. But then this division between the two tables or two relations is possible if and only if there are some rules that you can divide R1 and R2 only if attributes of R2 is proper subset of attributes of R1. Now what I mean by that is that, let's say, assume that R1 is one table and R1 has two columns A and B. That is attributes. A and B are attributes of R1. And R2 is another table which has only one attribute B. Okay. Now, is R1 divides R2 possible? Can you divide R1 with R2? Check the rule. The rule is you can have R1 divides R2 only if the attributes in this denominator R2, attributes in the denominator is a subset of attributes in the numerator. What are the attributes in R1? A comma B. What are the attributes in R2? Only B. Yes, this B is a subset of attributes of R1. Check that as another example. Suppose I have two tables R1 and R2 again, and I want to divide R1 with R2. Let's say R1 is having two columns A and B, and R2 is having two columns B and C. Now, is R1 divides R2 possible? No is the answer. Straight away, it is not possible. Because if you want R1 divides R2 to be done, then what are the attributes of R2? B comma C. Is this a subset of attributes of R1 A comma B? No, because this C is odd man out here, which doesn't occur in the other set. But then still, check that, still you can perform divides operation between R1 and R2. How exactly? Yes, you might have easily found out yourselves that if you want some way or the other the division to be done in one way, then what you can do is to do R1 divided by R2 over here. You can say R1, which contains A and B, correct, divides R2, but R2 has the C odd man out, which will disobey the rule that R2 should be subset of R1. Then you can use project operation and only get B from R2. Just check this. What will be the result of this project operation is that this project operation will give us a new table, a temporary table, which will contain only column B of R2. Now clearly, this right hand side table or denominator table has only B. And clearly, this B is subset of A comma B. This is the rule. This is the rule for division. Now the other thing, just check the very important point. What will be the result of R1 divides R2? See that the relation returned by division operator will have which attributes? It will have all attributes of R1 minus all attributes of R2. To understand this, suppose R1 has AB and R2 has B, and we want to do R1 divides R2. Now it is possible because B, this attribute, is a subset of A comma B. But then what will be the result of R1 divides R2? In R1 divides R2, we will get only one column A under which we will get values. That means it is nothing but all attributes of R1, which is numerator, correct, minus all attributes of R2. you know in that case that the common part between R1 and R2 won't be shown in the result, but the result will contain only A. I hope you are understanding. Let's take one more example about the result. Let's say R1 is a table which contains A, B, C, D, four attributes, and R2 is a table which contains A and B. Now, is R1 divides R2 possible? Yes, because the attributes of R2, the denominator, is subset of ABCD. But what will be there in the result of R1 divides R2? In R1 divides R2, we will see only two columns, C and D, under which we will see values of our result. So this subset, which was common in R1, won't be shown in the result. I hope you have understood the rules when you can do R1 divides R2, and you have also understood what will the result contain. But then finally, what is divide operator all about? What does it do? Here we go. The relation returned, check this point, the relation returned by division operator will return those tuples from relation R1. Check this, it will return those tuples from relation R1, the numerator tuples it will return, which are associated to every R2 tuple, that is denominator. What am I talking about? Before I show one very interesting example over here, let me build one arbitrary example. Suppose I have two columns A and B in R1 and only B in R2. And I am flooding some values over here. Let's say the values are 1, 1, 1, 2, 2, 1, and let's say 3, 2. And in B, I am having two values 1 and 2. Check this. R2 is having only one column B, whereas R1 is having two columns A and B. Okay. Now we are doing R1 divides R2. You very well know you can do R1 divides R2. The subset rule is really followed over here. So what will R1 divides R2 contain? Just check. What it will contain is definitely the result will contain only A, because you know the result contains all attributes of R1, that is numerator attributes, minus all attributes of R2. So the common column B won't be shown. By the way, the result will contain only those tuples from R1. Just check. Only those tuples from R1 which are having or which are associated with every tuple of R2. Let us check what are the values in R2. Values in R2 are 1 and 2 under B column. Values in R2 are 1 and 2. Then we see that which of the tuples in R1, for which values of A in R1, both these values are present, 1 and 2. Let's check. When the value of A is 1, check this, when the value of A is 1, we have got value of B as 1 and 2. That means 1 is such a value under A column which is associated with all the tuples of B. So in the result, we will get 1. Let us check this value 2 under A. 2 is associated with 1 and 1 is present in the other tuple, in the other relation. But unfortunately, this 2 is not associated with the other value 2 of our other table. Similar happens to 3. 3 is associated with 2, but 3 is not associated with 1. So in our result, we will get only this value of A is 1. I hope you are understanding. Very, very quickly, I'll build an example and you can pause the video and you can ask what will be the result of R1 minus R2. Let's say we are having these two tables this time and we are having some values in this fashion. We are having 1, then 3, then 2. Let's say we are having 2, then 4, then we are having 2, 3, then 1, 4, and let's say we are having 2, 5. And under A, we are having 1 and 2. So what will be the result of R1 divides R2? R1 divides R2. Now you just check, R1 divides R2 is possible because R2 has only A attribute and R1 has A comma B. So denominator is a subset of numerator. But then what will be the result in R1 divides R2? Come again, what will be the result in R1 divides R2? Yes, only B will be the result. Correct? Because this common column won't be shown and R1 divides R2 will contain the result as B. But then what are we talking about B? We will check this B column in R1 and only those tuples of R1 will be shown which are associated with every tuple of R2. So let's take the value of B as 3. B as 3. Check this. In these both tuples 3, 3, you can see the associated value is 1 and 2. And indeed that are all the values in R2. That means 3 is such a value under B which is associated with all the tuples. So 3 will be shown. Let's check another value under B, 4 and 4. Just check this value 4 under the column B is associated with values 2 and 1, which are indeed all the values in R2. So even 4 will be shown in the result. But just check this value 5 in the column B of R1. But phi is associated only with 2. Phi is not associated with 1. So phi is such a value which is not associated with all the values of R2. So phi won't be shown. And this is the result. I hope you have understood what is R1 divides R2. Let's check an application or let's check the importance. Where will you use this divides operation? Now let's consider two relations R1 and R2. I could have named them better. The names could have been student instead of R1 and sports or all sports instead of R2. Let's say the relation R1 has roll number of the student and sports that the student plays. I have given some arbitrary names for the sports. I could have given badminton, cricket, and so on. But to keep the names concise or smaller, I have given S1 and S2. It shows that there is a student roll number with roll number 1 who plays the sports S1, or there is a student with roll number 2 who plays sports S2 and S1 both, and student number 3 plays S1. Now coming to R2 table, this is another relation. We have shown which sports are offered by our organization or maybe by our college. Our college offers two sports, S1 and S2. So these are all the sports that a student can play. Now observe that although these are all the sports S1 and S2 that a student can play, there are only a few students who play all the sports. So we want to find out, just check, we want to find out students, that is roll number, of course. We want to find roll number of the students who play all the sports. All the Just check this word all. This is interesting. And whenever you have got any such query in relational algebra or SQL, you will use divide operation. You want to know which are the employees who work in all the departments. Okay. You will use all. You will use divides when you want to do this between the two tables. So come again. Who are the students who play all the sports? It's very easy. One does not play all the sports because one plays only S1 and this S2 you see, S2 is missing. There is no entry called one plays S2, isn't it? There is no such entry. So one should not be in our result. But two, roll number 2 is playing all the sports. Notice S1 and S2 are the two sports offered. Then this roll number 2 plays all the sports, whereas 3 does not play all the sports. 3 plays only S1. So in our result, we should get roll number, only one column with the result 2. That will be done by doing R1 divides R2. Come again, is this possible? Yes. Check that R2 is containing only one column sports, whereas R1 is containing roll number and sports. Clearly notice R1 divides R2 requires R2 should be subset of R1 and clearly sports is a subset of roll number and sports. And in our result, sports won't be shown, only roll number will be shown in R1 divides R2, and you know how this 2 will be shown. So all these things, all these things I have explained over here. You can pause the video and you can read out how this particular R1 divides R2 has given the result as roll number equal to 2. As another example, just check. R1 is a table which has roll number and course. Now, what this table shows is the roll number of the students who have enrolled for courses. I have given the name of the courses as C1, C2, some arbitrary names. Now, this particular relation R1 is actually showing that roll number 1 has enrolled for course C1. Roll number 2 has enrolled for course C2, whereas roll number 3 has enrolled for two courses C1 and C2. Good. But which are the courses offered by our institute? Now there is another relation R2 here which has course names. So C1 and C2 are the total, all the courses offered. But notice there is one more column here, duration of the course, maybe in hours or days, 45 hours and 100 hours. Now we want to know roll number of the students. Just check. Roll number of the students who have enrolled for all the courses. And you very well know the result should be 3, because 3 is the roll number who has enrolled for C1 and C2 both, but 1 and 2 have enrolled only for C1 and C2 respectively. But then there is a problem. To do R1 divides R2, R2 should be perfect subset, proper subset of R1. But there is a problem. R2 is containing a duration column. Just check. So it doesn't make R2 a subset of R1. So what? We are interested only in matching roll number with courses. We are not interested in duration as far as this problem is concerned. So what? We can do project operation on R2 and we can pull out only this column. I hope you are understanding. Only this column and then do divides. Hence, the relational algebra expression would be R1, which is containing roll number and course. This is R1 divides. Now you see from R2 I am projecting only course. So this is going to contain only course, and then you know rest how divides operation will pull out only roll number 3, who is the student who has taken all the courses. I hope you have understood what is divide operation, but I told you that I have divided this particular topic of divides operation in 3 videos. In the next video, I will show you that actually divide is an extended operation. This is known as extended operator of relational algebra. That means actually division is performed by using cross product and minus operation. Okay, so it's not purely an operator. You can think of that divides operation is implemented using these basic operators. More on this in detail in our next video. Thank you very much.